we need to be able to craft a perfect summary mask anytime we perform route summarization. We have to be very careful. Here there's a pitfall to be had. But I want you to look here. We've got 4 networks to summarize. I've got 4 networks to summarize. Well, what they've done is they've broken out the binary of those values. How kind of the graphics folks to have broken out the binary so that they've calculated the second octet is .10 through .13, and they've given us the binary for that. What we could do is this. We could count the number of common bits that we have. That's really what summarization is trying to do. Count the commonality, find the commonality. So I need to pull back the mask up to where the commonality stops. I need to say, you know what? Originally these networks had a /16 mask. I'm going to try to dial back the number of bits of my mask to open it up wider, to include all 4 of these networks. So they've converted .10 to .13. And you can see the progression here. Looks good to me. If I were to try to find that commonality, I know that the commonality stops somewhere in the second octet, specifically where? After the first 5 bits. The commonality stops there because then we start to get into a 0 for the top 2 and a 1 for the second 2. So how many common bits do we have? We have a total of 13 common bits. And if you know the number of common bits, you could say, that's my new summary mask. That is my summary mask, which would be inclusive of these 4. Now, we've got a problem on our hands. The problem is, this in fact would include everything from 8 to 15. Why? Because in fact, if you notice right there, the key part is that the first value, the first of the networks we are to summarize, is not the 0 subnet. It is not zeroed out in the non-common bits. And in that case, you've got a problem on your hands. That means you're going to be summarizing more than is in your list right now. And if those networks exist elsewhere, you've just lied to the network. You've built in a problem. It might not be immediate, but when you advertise a summary, a route summary, you are saying, I have it here. And people will try to route to you. Routers will try to route to networks that may not be in the list. What about .9, .8? Your summary would have advertised for that. So here is a word of caution. You can check this. You can check this. Firstly, I would convert my summary mask to dotted decimal again. Why do that? Well, sometimes I do this. If I were to look at my subnet mask, this would be the subnet mask of my route summary. What we can do is this. We can find the block size. The block size is the boundary octet of my subnet mask subtracted from 256. Follow with me. I'm going to take 256, which is just a significant value for us, and subtract the 248 of the boundary octet. Now the reason why I'm doing this is to find the block size. It's basically the increment of subnets. And if I do that, I'm going to get 8. Here's the test. Your first subnet should be a multiple of your block size of the summary. The block size of the summary is 8. That is derived from the subnet mask. Find the interesting octet in decimal form, subtract it from 256, and count off by 8. 0, 8, wait a minute. This would have worked out really great if my first subnet was .8. And that would have given me a 0 network to begin with. So really a better way to go would be this. Can you think of a better way to go to only capture the right subnets? I would in fact build 2 summaries. If I had to summarize, I would do this. 10.1.10 and 10.1.12. These each would capture 2. They would capture 2 of the subnets. And I could validate that my block size is appropriate, because if you're looking at a /15 mask, that's a 255.254, which means my block size is 2. Counting by 2, well, yeah, if I'm counting by 2, the .10 network works out perfectly, the .12 network works out perfectly. So be very careful when you are summarizing networks. Make sure to only capture the subnets that truly exist in the desired range of what you're trying to summarize.